Hello there, this is a geometry video. It is chapter 5, section 6, and this is the last section of the chapter. So you know what that means, test coming up pretty soon. Today we're talking about inequalities in two triangles. In a previous lesson we already did inequalities in one triangle. And today's theorem is called the Hinge Theorem. And if you don't know what a hinge is, it's kind of the little thing that your door hangs on. And so here we go with the theorem. It's actually not a very complicated theorem. When you read the theorem, it sounds a lot more complicated than it actually is. But I'll read it first, and then I'll show you with an example what it actually says. So it says if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. So see, it sounds very wordy, very confusing. But let's just go back real quick. We have examples here. Two sides of a triangle are congruent. So we know in the diagram that AB is congruent to FG, and we know that AC is congruent to FH. So two of the sides of the respective triangles are congruent. Furthermore, the included angle, and we did that before with side angle side, we've done that before. Included angle means the angle in between the two sides. So angle 43 is the angle that is included here, and angle F, which is this 30-degree angle, is the angle that is included in this triangle. So not only do the sides have to be congruent, two of the sides, the angle that is included doesn't have to be congruent, but has to be larger. So 43 is larger than 30. So that's the second part, is that the included angle of the first triangle is larger than the included angle of the second. If all of those things happen, then the theorem states that the third side of the triangle, the one that's here in red and here in blue, then the relationship between those two sides is that this side is going to be longer or larger than the third side of the second triangle. So basically BC would have to be larger than GH. We also have a converse to the Hinge theorem. And the converse of the Hinge theorem, I didn't write on the board, but you already know how the converses work. It basically goes backwards. So in the converse of the Hinge theorem, we have the same prerequisites, which are that the two sides of the triangle are congruent to two sides of the other triangle, but the second part is that the third side, so the converse would say that if the third side is already bigger than this third side, then the converse would state that the angle over here would be bigger than that one. So you reverse the angle on the side portion of the theorem. And I'm going to ask Angelique to not talk. Please. I can hear you. They can hear you. All right, so we're going to start with the examples. And it says here to compare the given measures. So it says to compare WX and XY. So WX is this segment here, and XY is this segment here. But we want to look at the components that they've given us to see if we can determine anything based on the Hinge theorem. And we can, because we know that WZ and YZ are congruent because they're marked congruent. And we also know that XZ is congruent to itself because it's a shared side between the two triangles. So now we have two of the sides of each triangle congruent, and then we also know that the angle here, angle XZY, is 55 degrees here, so this one is larger than this one, which means that XY is larger than WX. So that's basically what we can say about the measures. You could also say, for example, that WX is less than XY. That's the same statement. When I say XY is bigger than WX, it means that WX is smaller than XY. Either way that you say that is okay. In part B, we're going to compare angle measures, not side lengths. So we're going to be using the converse of the Hinge theorem for this guy. So, but again, before we can apply the converse of the theorem, we have to know, first and foremost, that two pairs of sides are congruent. And so we have BF marked congruent, and we have CD marked congruent. And again, we can use that FC is congruent to itself. And so now we have two sides. And we also know, according to the converse, we have to know that BC is already bigger than FD. So 3.6 is obviously larger than 3. So we know that BC is larger than FD. So because the third side is larger, then we know that the angle that is included in this triangle is going to be larger than the angle that is included in this triangle. So The angle in question here was FCD, so FCD is this angle here. I'll just call it angle 1. And BFC is this angle here, we'll call it angle 2. And since this angle is in between the two congruent sides, this angle is in between the two congruent sides, and this is a larger side than this guy, then that means that this angle 2, which is angle BFC, is going to be larger than the measurement of angle FCD. And that's how you apply the Hinge theorem to compare measures. So now we're going to ask you to try these two examples on your own, and then we're going to move on to another application of the Hinge theorem. And here we go. I drew this little diagram. It's a little big, sorry, but bear with me. It says, two groups of snowmobilers leave from the same base camp. So here's base camp right there. The first group, Group A, goes 7.5 miles due west. So that will be this direction. This is the westward direction. So that's what I drew this little guy here for, 7.5 miles due west. And then they decided to turn 35 degrees north of the west direction. So now they're going to go in an upward direction at a 35-degree angle. So that's kind of what this represents right here. And they do that, and they go for about another 5 miles. Group B does pretty much the same thing, but they start off going due east. So they go this direction, 7.5 miles. And then it says that they turn at a 40-degree angle north of the eastward direction, and then again go 5 miles. And it's asking at this point which group is farther from the base camp. In other words, which segment is longer. And so again, we can use the Hinge theorem to figure that out, because we know that two of the sides of each respective triangle is the same. We know that 7.5 and 7.5 are the same. 5 miles and 5 miles, so they're the same. And then we have the included angle. We know that this part of the angle is 35. So very quickly we can take 180 and subtract 35 and get 145 for this little guy. And over here we can take 180 and subtract 40 and get 140 for the other triangle. And so now we know that I think this was Group A, right? So the Group A triangle, yeah, here we have A. The Group A triangle has a larger angle that is the included angle of the two sides than the Group B triangle. And so since this angle is larger than that angle, then the segment AC is longer than the segment BC. So which group is farther from the base camp? Group A, based on the Hinge theorem. So that's how we would explain our reasoning. You'll have to write it all out, but that's basically what you're going to want to say. Alrighty, so now we have two little dudes for you to try. Very similar scenario in Do-It-Yourself 2A. Two groups of skiers this time leaving from a lodge, but very similar scenario. Keep in mind that they want to know who's farther, but in part B, they want to know who is closer, so the shorter distance. So just keep in mind that that's happening there in Do-It-Yourself number 2. So then we're going to go on to another application of the Hinge theorem, which is algebraic in nature. Okay, so it says, find the range of possible values for x. So the first thing we have to do is apply whether or not we can even use the Hinge theorem. So we see that JH and GH are marked congruent. And again, we have this EH segment, which is a shared side between the two of them. And so because of that, we know that we can almost apply the Hinge theorem. But I think that in this case, we're going to want to apply the converse of the Hinge theorem. And the converse of the Hinge theorem says that we have to know the third side. So we know that the third side is over here 11, and the third side over here is 9. So 11 is larger than 9. So we know that JE is larger than EG, or GE, sorry, I should write that the other way. So JE is larger than GE, which means that the angle here is 6x plus 15. has to be larger than the 65 from the other triangle. According to the converse of the Hinge theorem, that relationship has to happen. So now all we have to do is find the value for x. That's our first part. So 6x is greater than 65 minus 15 is going to be 50 divided by 6. And I'm sure that that fraction reduces. So 50 divided by 6 is going to give us 8 1/3, which basically is 25 thirds. Okay? So we know that the x value has to be larger than 25 thirds, but we also have to consider the fact that the measure of any angle in a triangle has to be less than 180. So we also have to write that 6x plus 15. So we don't want to say, like right now we're saying that x can be bigger than 8 1/3. So basically it's saying that it can be 200 because 200 is bigger than 8 1/3. But clearly we can't allow x to just go on forever and be as large as it wants to be as long as it's larger than 8 1/3. So we also have to keep or make sure that that no angle in the triangle is larger than 180. So not only does 6x plus 15 have to be greater than 65, 6x plus 15 also has to be less than 180. And so then we solve that inequality. And that's how we get our range of value. Because when you talk about a range, you're supposed to have two boundaries, two numbers that the value should be between. And so we have our first number over here, and we're going to get our second as soon as we finish this little guy. So 165 divided by 6 is 55 halves, or basically 27.5. And over here we get 8 1/3, or basically 8.33333 repeating. So to write our final answer, we just write it as a range. We say x is in the middle, and it needs to be less than 27.5, but greater than 8.3 repeating, and that would be our range. So now we have two values within which our x value should be found. So now you will try this little guy, and then we will move on to our favorite, El Prufo. I know you guys don't like proofs, but I assure you proofs are your friends. Okay, so they want us to write a 2-column proof, and they're giving us some information. I've kind of already gotten the basic stuff started for you, but it says given that AB, so here's our segment AB, is congruent to AD. So keep in mind that even though I put the tick mark right here, it's actually the entire segment A to D that is congruent to A to B. And they're also telling us that they want us to prove, that EB is greater than ED. So EB would be the third side, okay? So what's going to happen here, what you're probably not realizing, is that AE, this side right here, is a shared side. So the two triangles I'm looking at are triangle AEB and triangle AED, which are kind of overlapping right now. So the shared side here is going to be my second side. So I'm going to go ahead over here and put AE is congruent to itself by the reflexive property. Alrighty. We already wrote that AB was congruent to AD. So now I have two of the sides. And so now we have to figure out a way to get the angle measure. If I can get the angle in between the two sides to be, one to be larger than the other, then I can continue and finish my proof. So the next step is going to be the measurement of angle EAB. Let's see, I hope that it fits here. So here's EAB. So this angle measure, which is the angle included between AB and AE for the first triangle, is broken up into two pieces. So the angle addition postulate says that I can add those two pieces together to make the whole. So EAD plus the measurement of, let me see here, EAD will be DAB. Oh no, I don't have enough space. Let me break in here a little bit. Angle DAB. That's funny. Alrighty, so I had to move the line around my statement there. So the measurement of angle EAB is equivalent to the measurement of EAD plus the measurement of DAB. So these DAB, this angle and that angle together make up the whole angle. And the reason for that is angle addition postulate. So angle addition postulate. And so I hope that makes sense, okay? Because the included angle of this triangle right here is EAD. The included angle of this triangle is EAB. So right now what we're going to say then is that the measurement of angle EAB is greater than, so EAB is greater than EAD. Alrighty. So now I want to show you that where that came from. So again, I'm going to go back to my diagram so you can really see what's happening here. First, we took the angle EAB, which is this combined angle here, and we stated that that angle is made up of two pieces. So we put that EAB was equal to those two pieces. So then now what I want to show you is in a different color. The angle that the arc that I just drew is the included angle of the EAB triangle. But this angle right here, which is EAD, is the included angle, these two sides, the included angle of the AED triangle, okay? So what I did in step 4 was, since I know that this angle is equal to both of these together, then obviously this angle must be bigger than any one of these angles by itself. So EAD is here and EAD is here. So basically EAB is larger than EAD, and that's because of the definition of inequality. That is the definition of an inequality. Is that if there are two that are equal to 1, then the 1 is bigger than either one of the others by itself. Okay, so once I've done that, I now have my Hinge theorem in place. I have the two sides congruent. I have the angle in between them that is larger than this one. Therefore, the third side, which is ED, is larger than the third side of the second triangle, which is ED, and that's by the Hinge theorem. I'm just going to write Hinge, put my little Helmos right there, and then call it a day. So now you can try this little guy, a very similar fashion, and then we will do one mass proof. In this case, I kind of already wrote the proof out for you, but I want to go over the steps with you so that you can see what happened. But basically, they're asking me to write a 2-column proof, and they're telling me that T is the midpoint of ZX. So here's T, the midpoint of ZX. That's my first step. And because T is the midpoint, that means that ZT and XT are the same. They're congruent by the definition of the midpoint. That's where step 2 goes. Then I go to my second given statement, which is that ST is congruent to WT. So I'm going to go ahead and write some of these things in here. So we know that this is congruent to that. And now with ST congruent to WT, that's given. All right. So now we also know that SZ is greater than WX. So SZ is over here. this guy is greater than WX. So if that's greater than WX, then by the converse of the Hinge theorem, then the included angles, which are these two angles here, angle 1 and angle 2 here, those angles, since SZ was larger than WX, then this angle is larger than this angle. And that's what you see in step 5. The measurement of angle STZ is greater than the measurement of angle WTX by Hinge converse. It is the converse there. Okay, so then we have a couple more steps to go through. We know that this angle is bigger than that angle, but we also know that these two angles, so be careful here, don't get confused. We're talking about angle 1 and angle 2. But now you have angle 1 is a vertical angle with this angle here, which is XTR, and angle 2 is a vertical angle with this angle here, which is ZTR. So what I've got here is two different statements that basically state that those two pairs of triangles are vertical angles. Then I know that because they're vertical angles, they're going to have equal measure. So that's the definition of congruent angles for step 7. And then lastly, I'm going to use substitution because I know that STZ is greater than WTX, but the angles that I'm trying to prove bigger are XTR, which is not those two angles. XTR is this angle here and this angle there. So I have to use substitution. So I'm going to replace XTR with STZ, and I'm going to replace ZTY with WTX, and that's what's happening here. I took the STZ statement here and replaced it with XTR, so you can see that it says STZ here, and then since STZ equals XTR, I replaced it, and then here it says XTR, sorry, here it says WTX, and I replaced WTX with ZTY because they're equivalent here. And so now I have my final statement that XTR is larger than ZTY by substitution from steps 5 and 7. So that's your last proof there. So you have to write one more. In this do-it-yourself question, I've kind of filled in where things need to be. So there's 3 steps in between here that you need to fill in, and of course the last step. And once you have done that, you will have completed your notes for this lesson. And I will see you in class. And thanks for watching.